上集说到的高密度接入仅仅是无线网络部署时遇到的难题之一 ，WiFi 漫游其实是另外一个难题。事实上，建设一个成功的企业无线局域网的另外一个重要方面，就是确保足够的 WiFi 漫游性能。下面让我们来看看思科无线测试实验室是如何来进行无线漫游性能测试的。思科的无线专家将为您揭开实现高性能无线漫游的秘密。Now we see a track on the graph. It's a track of a Model 3. In fact, it's a test bed. I would like Wes to introduce it for us.
Sure. So this is our roaming test bed. It's meant to simulate a person walking around an office building. So we've set up this model train throughout the building with 4 access points, and we watch as it roams from AP to AP.
So, what is roaming technology? Why roaming is a big challenge for wireless network? How to test roaming performance?
Wi-Fi roaming is an often tough subject because fundamentally the roaming decision is left to the client. For example, on a cellular network, it's the cellular network that tells the client, okay, I want you to roam to this tower, you're going to roam to that tower. But with Wi-Fi, the client is making its own decision, and some of the clients are not the most intelligent about making their own roaming decision. So you can have what's called a sticky client, where you have a client that is very far from an access point and can hear another access point very well, and he should have roamed to that access point, but he didn't because he either doesn't know any better or he didn't start scanning, so he doesn't know that there's another access point. But regardless, he's sticky and should have roamed. So what can be done about that? Well, not very much, unfortunately. The infrastructure can take aggressive action and send a disassociation so the client roams, or the infrastructure can arrange itself so that the client will start to scan by, the infrastructure can lower its power levels so the client will start to scan and roam more efficiently. There's also other issues such as there needs to be some sort of mechanism to allow the client to roam roam quickly on a secure network. So Cisco has for years supported and actually pioneered fast roaming with technologies such as CCKM, and now that technology is kind of transformed into 11R, which is a standards-based fast roaming mechanism, and also 802.11k, which allows for the access point to send what's called neighbor lists so the client knows what the RF environment looks like. Here we are in our roaming test bed. To simulate a person walking around an office building, we have a model train. The train is great because unlike a person, it always follows the same path, and therefore we have repeatable roams. We're also going to use an iPhone for the test, just to simulate a person with a smartphone. We're using 4 AP2700s spread around the building, and our controller configuration has followed our best practices, such as disabling the lower data rates. On the WLAN, we have 802.1x with also 11R and 11K enabled. RRM has set a channel plan and a power plan, and it's really the power plan which is going to allow the client to roam efficiently. The train always follows the same path, so tests are repeatable. We set up 4 APs throughout an office building, configured with 802.1x security. 802.11r and K were also enabled. Not every device supports 11R and 11K, but the ones that do enjoy speedy roam times. So we find with 11R, it's no longer about the speed of the roam because the roams are always fast. It's about the roaming consistency and predictability. For example, if we looked at one of our competitors, their radio resource management assigned APs to full transmit power. So the client stuck to one AP and never roamed. Because of this, as the train moved around the building, the competitor had inconsistent throughput with a high retry rate, which would lead to poor application performance. Cisco, on the other hand, maintained consistent throughput with a low retry rate. You can even see the two roams. To help facilitate the roaming, we manually lowered the output power on the competitor's APs. Even in this test case, the competitor still did not roam consistently or predictably, whereas with Cisco, you knew when and where the client was going to roam. So as we've seen, the infrastructure plays a critical role in the roaming process, even though it's the client who actually makes the roaming decision. So during the roaming test, we saw that 802.11r and 802.11k were very important to the roaming process. They allowed for the roams to happen quickly, efficiently, and repeatably. But there's also another critical element which Cisco differentiates upon, and that is Cisco's Radio Resource Management, or RRM. The channel plan and the power, more importantly, the power assignment that RRM assigned allowed for the client to say, okay, I need to start thinking about roaming here. I'm getting weaker on this access point, and let me see if there's a better access point nearby. And the answer was yes, there's another access point, so let me roam here. Where other infrastructures that don't have a radio resource management that's optimized for roaming will assign too high a power levels for the access point, so the client will not want to roam and he will become a sticky client.
从上面的测试，您可以看出一些实现无缝漫游的门道，比如思科通过一系列的优化漫游技术，允许客户端设备主动查找无线接入点，并使客户端快速地切换到一个质量更好的连接。思科还通过结合射频资源管理这一技术，帮助客户端实现高性能的无缝的连接可靠的漫游，为 Wi-Fi 用户带来极佳的漫游体验。